Hi, we are going to do simple harmonic motion and Hooke's law experiment. Here we are going to verify what we call Hooke's law, calculate the spring constant of this spring, and then verify the acceleration due to gravity 9.8 meter per second squared. Here are the equipments that we are going to use. First, we are going to complete or accomplish table 1. How to do that? We will take a mass, in this case 20 gram. This will stretch the spring according to Hooke's law, and then we will use the Data Studio software to record the vibration of the spring, and we will record the time it takes for 10 vibrations. So how do we do that? First, extend the spring to give it a simple harmonic vibration, and then click Start. You will see on the Data Studio software, the display is actually a sinusoidal wave, and this is what we are going to measure. Once you have 10 waves, you just click Stop. You can hold the spring, you can remove the mass, especially if it's extending the spring too much. And then let's focus on the Data Studio software. You can choose any of the 3 graphs. Just take the linear fit, just take the Smart tool. Place the Smart tool at the top or the peak of the graph, and from there take the Delta tool and slide it until you have 10 complete waves. So how do you do that? Just count. From where you begin, that's 0. This is 0. That's 1 wave. 2, 3, 4, 5, 6, 7, 8, 9, 10 waves. Make sure that you have the complete count, so count again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number that you have at the bottom here, this is delta of the x-axis. That means that's the time it takes to complete 10 vibrations. Record it in your data sheet. Once you've finished, add another 20 gram mass. This will stretch the spring further. You can go to your graph and go to data, no data, or you can simply erase everything by doing experiment and delete all data runs. Okay, you can remove the Smart tool and start again. Stretch the spring a little bit. This will give it a simple harmonic vibration. Make sure that the vibration is vertical. If the vibration is wild or swinging left and right, this is not going to give you a good graph. So again, calm the spring, pull it down, give it a nice smooth vibration, and click Start. Again, you will get your sine wave. Make sure that you have enough waves to have 10 vibrations. And once you do, click Stop, take the Smart tool, go to the peak of the graph, get your Delta tool, and then count 10 waves. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vibrations. Again, record the time it takes to complete the number of vibrations. Now that we've finished table 1, let's continue with table number 2. In table 2, we are going to add a mass and stretch the spring, but this time we will not make it vibrate. Instead, we will we will use the relationship of mass as well to the extension of the spring to find or verify the acceleration due to gravity. In order to do that, we need the spring constant, which we can calculate from table 1. So how do we do it? We are going to make a table of, in our software, we are going to make a table of position versus time. Okay, that's how we do it in the video. And then we are going to make sure that the spring is steady. Okay, maybe it's as steady as we can. And then when you click start, what's going to happen is the software is going to make a graph of a straight line versus time. This is the graph of the distance from our motion sensor up to our spring here. That will establish the original position or length of the spring. Adding 40 grams, for example, will stretch the spring, therefore giving it a longer length. If we click start again, a second line will be displayed, and the difference between these two lines will give us the extension of the spring. Using the slope of the graph and the spring constant, we can find the value of acceleration due to gravity by taking this measurement.